SAGIS Training video number 11. This is a very special video in which we will be talking about how to use Python with ArcGIS Pro to carry out data analysis and automation. My name is Pau Juan Garcia, I work at Atkins Realis, and apart from a water quality modeler, and you've probably seen me already in some of the previous videos, I'm also the maintainer of the SAGIS Add-in as well as the new RQB software tool. My journey with Python started many years ago, where I started using it for my PhD in data analysis and manipulating modeling outputs. From there, I've been progressing into using it more often in all of my projects until I decided to get more involved in software development here at Atkins Realis, and slowly I started managing the code base of smaller projects, and more recently SAGIS Add-in and RQB, which are my most two notable projects and the ones that I'm the most proud of. So the purpose of this video is for me to show you the possibilities of using Python with ArcGIS Pro, and I'll try to orient it to specifically SAGIS projects. So what you can do with a SAGIS model database and Python in ArcGIS Pro. How can you speed what I consider to be common workflows or extracting data that you might need to extract repeatedly across several models and that might be useful. And also giving you an overview of the Python ecosystem in ArcGIS Pro in general. Hope you find it useful. Let's dig in. So firstly, I would like to explain why is Python so popular? Why is it that we're talking about Python? If you Google what are the most popular programming languages in 2025, you may find a website like this that will tell you that Python is the most popular. Now, how they come up with these ratings is explained in these websites. Usually it's about searches for a specific programming language and also different statistics about its usage. So why is Python the most popular language? Well, it has a massive increase of almost 9% in ratings this year. It is the go-to language for AI, data science, automation. It's very simple, which makes it very appealing to when you start learning programming. It has a arguably easy syntax that allows you to start coding right away. And there's been, because of this growing community, many useful packages that have been created in Python and that people has used. And once you have those tools that you need in one programming language, it's very difficult to switch. Python has spread to almost every other tool that we use. For example, you can find Python in ArcGIS Pro, you can use Python in QGIS, you can use Python in FME by creating your own blocks of code that use Python. You can use Python to download data from the Environment Agency's API, for example, the WIMS dataset. You can use Python in Excel. For example, the new Copilot in Excel already asks you if you would like to create graphs in Python and embed them in Excel. It has really spread to many other tools because people want to leverage the power that Python brings, especially in terms of data analysis, into their other daily tools. I think the reason why it has become so popular for data analysis and data-related tasks started with this library, Pandas. So this library was a game changer. It was developed by a guy called Wes McKinney. Basically, he was frustrated by the lack of code that would allow him to manipulate data in an intuitive way, the way that he wanted to do it. So he decided to write his own library. And it has become so widely successful. It's almost a requirement, unless you're using another bespoke tool like SPSS or R. If you're working in Python and doing anything that contains the word data, you know about Pandas. And of course, Pandas is going to be very useful when we manage the tabular data that we know in ArcGIS Pro, such as tables, feature classes, and so on. The second reason why it has become very popular, I think it's because what we call the Jupyter notebook. This is a new type of interface. It's a project that received a lot of funding because of how popular, again, it became. And basically, it's a simple idea where you have a notebook-like interface where you can write actual text in Markdown language, so with syntax highlighting, bold casing, size, different, being able to assign different size to the letters, titles, and so on, and mix that with the different snippets of code that you are using to analyze your data. And it's a very intuitive and useful way to create a workflow of data analysis that you can then share with someone else and reproduce. We are now in ArcGIS Pro. So where can we find our Python installation? Well, if you go to Project and then Package Manager, here is where we can manage our Python environment. So as you can see, the default environment is called ArcGIS Pro-Py3, which indicates that you're using Python 3 point whichever subversion. And Python by itself is not going to be able to do much. The power comes from all its different libraries. So all of these are the libraries that come installed by default. As you can see, Pandas is already here. Let me just find it. There we go. As well as OpenPyExcel, which is a very popular library for manipulating Excel files, as well as NumPy, which is the all-powerful numerical manipulation library in Python. And I won't go through the whole list, but a couple of them that are worth mentioning is ArcGIS and ArcPy. ArcPy in particular enables you to use any S3 ArcGIS Pro geoprocessing tool directly from the Python command line. To find Python in ArcGIS Pro, we need to navigate to the Analysis tab. And from there, Python is in a very prominent position in the top left of the tab. By default, the Jupyter Notebooks option is selected. I would recommend that we start, when you start training and discovering Python, with the interpreter, which might be a bit simpler. So the Python interpreter, or Python command line, it's an interface for you to interact with Python, and therefore with the ArcGIS Pro project using Python. How we do this? So for example, imagine you plot your outputs. So here we have plot outputs for phosphate, and then you did the same thing for ammonia. And you wanted to try a new symbology, but you ended up with a symbology that you actually didn't like very much. As you can see, that's not very pretty, it's too small, only 5 classes, not particularly appealing colors. So what you want to do now is revert it to the original. We could do this, for example, by going to the Geoprocessing tab, going to Apply Symbology from Layer, and just saying, well, since I already have mine here, this phosphate one, I'm just going to do, please select this input layer and apply the symbology layer from phosphate. Now, an easier way could be, for example, from Python, just type ArcPy, the library that will give you access to all of the geoprocessing, and then apply symbology. And as you can see, it will automatically filter down to the geoprocessing tool names that match the text that you have input. We select it, and we can see it's asking you to input the input layer and then the symbology layer, the same inputs that you would see in this pane to the right. So we will do that. It automatically gives you the option to select all the valid inputs that it can detect. So we're going to say that we want to apply a symbology to the ammonia layer from the phosphate layer, close the parentheses and press enter. And then that's done, as you can see, automatically. Now, the second thing you might be thinking is, well, that's all very well, but how do I know which is the command that I need to input? It might be good at filtering the ones available, but that still looks a step back from basically just searching them in the geoprocessing menu. Well, it's actually very simple. You just look for a command that you want to know how to write in Python in the history of the geoprocessing. Like, for example, the one that we just used within SAGIS, right-click and say Send to Python window. And automatically you get that command with all of the inputs, no matter how complex. This will work with Open and Update, with Create Simcat, into your Python interpreter. And if we, for example, remove this one from the map and run this, it would be just as if you would have launched it directly from SAGIS. So now we send the same process and we create the exact same layer. You can see there's a suffix 1. That is because we didn't delete the previous one, we simply removed it from the map. So it has created a duplicate with a 1. But there you go. These are your first steps in automation. We have launched a SAGIS process. not from the SAGIS tab, but instead from the Python interpreter. Next, we're going to take a look at how to use Jupyter notebooks. Jupyter notebooks have become so popular that Esri considered and indeed added them to the toolset in ArcGIS Pro. In order to create a Jupyter notebook, you simply need to click on this New Notebook button in the Analysis tab, and it's generally the default way to work with Python. You can use the interpreter, and I think to get a feel for how Python works, that could be better. But quickly moving into Jupyter Notebooks will allow you to make sure that the code and the experiments that you do at the beginning are recorded and you come back to them to understand what you did at a later stage. So if we click here, a new notebook will be created. New notebooks will also appear in this drop-down menu called Notebooks in the Catalog pane. If you haven't created a notebook yet, this notebooks option won't appear, but it will appear automatically the moment that you create your first notebook, so don't worry about that. In this case, I have already prepared a notebook for the tutorial. So as I was saying, you can put text next to your code in the notebooks. So for example, if we create a new cell, it will by default be a code cell. Now, if we make it a markdown cell, I could write something here, and it's just text. If I want to make it a title, I will add a hashtag. If I add 2 hashtags or 3, then it's a title of level 2, level 3, and so on. You can also create lists very easily. For example, if I write first item and then second item, that will be a list. If you add numbers followed by a dot, for example, then that will be a numbered list, and so on. So this is called the Markdown language. It's very simple. It doesn't have many commands. It's just a way for you to create syntax and to create text formatting in a very easy and intuitive way without having to actually require to go to different buttons to format the text. So for example, if we surround a word with asterisks, it becomes italics. If we do double asterisks, then it's bold, and so on. So this is something I will let for you to discover. But now let's jump into the code and how we can use Python to do some useful tasks. At the end of the video, I'm going to provide many resources because obviously this is a very, very large topic and it won't be possible to even scratch the surface with just one video. So bear with me, don't try to understand everything. At the very beginning, we need to import the libraries, the Python libraries that we're going to be using. So pandas, which I'm importing with a shortcut, pd, in order to call the functions without writing the full name. And also we need to invoke these two methods, GeoAccessor and GeoSeriesAccessor, which will allow us to read file geodatabase formats such as tables and feature classes directly into pandas. So once I've done that, I'm going to read SimFeatures as a specially enabled data frame. So I'll do that. And as you can see, this is SimFeatures. If I don't use the head command, then we'll see that there's a total of 80 rows and 215 columns in this map. The head method allows me to show the first 5 rows only, or I could just say show me the first 2 rows, just to make sure that the data has been loaded. Now, I also want to be very clear that using Python in ArcGIS Pro is a journey, and sometimes it can be painful. The reason I say this is because, for example, this spatial object method tool, let's just say, has a from table method. So if I come here, you see that this from table method pops up, just like from feature class that we used before to read sim features. Now I want to read sim discharges. And you would expect that this works. However, if we use it, it doesn't raise an error, but it returns an empty data frame. This is because at the moment this function is not working as intended. And I wanted to show this to make everyone aware that this is going to be a journey and not everything usually works the way that you would expect. and sometimes you need to check documentation, forums, the community in the developer community in S3 forums in particular is quite useful, and just check other examples to make things work. Now, that being said, this is the way that we read tables in SAGIS. It uses a feature class to numpy array method in order to read sim discharges. We need to retrieve the names of all of the fields that we want to read first, which we do with this part of the code. Long story short, if we do this, and then I show what this looks like, so sim discharges has been read into a variable that I call data frame, as opposite to spatial data frame, which I'm using for sim features. I could name them anything I want. Indeed, I could name them sim features and sim discharges. Perhaps that would be more telling. And now the data has been loaded, and we can just query it here if needed. But usually you won't query data directly from the notebook. That's something that you can already do in ArcGIS Pro. You use the notebook to automate a data process. So the next thing I'm going to do is a merge operation. I'm going to merge sim features with sim discharges on unique reference, which is the field that they have in common. And in doing so, what I'm going to get, if we take a look at data, is that because there's only 5 discharges in the Saglenda model, there's actually only 5. Oh, actually, no. Here we go. Because there's, so here, for example, I was assigning to data the .head method, which means that only 5 rows were being passed. We need to be careful. So data now contains 9 rows because there's 9 different discharges in this model. So I filtered sim features by only discharges using a merge operation with sim discharges, which is a table that only contains information about the flow of the discharges. There's many different ways that we could filter this information. So we could filter on feature type, which you can also do on ArcGIS Pro. And you can do join and merge operations in ArcGIS Pro, but I find them quite more involved than the way that you can do them in Python, where you can easily specify on which field you want to do it and you get the result instantly. Now, what can I do? So for example, if I want to get some statistics about the mean concentration of the first determinant, I can just run this cell. From data, give me mean Q1 and then describe it. And then I'll know the count, the mean, standard deviation, and several statistical moments about that particular column. Another thing I'm going to do is calculate the load. So I'm going to calculate the load by evaluating an expression on this data frame called data. I'm going to multiply the mean concentration of Q1 by the flow mean. I'll do the same for mean Q, multiplying it by the flow mean. So if we run this, if I scroll to the right now, you'll see that I have 2 columns, load Q1 and load Q2, now containing the load for those 2 determinants per discharge. So let's say that I want to generate some summary statistics. I'm going to hide this. You're probably familiar in Excel with the idea of a pivot table, which what it does is a very useful tool to pivot data and summarize aggregate data into summary statistics. So this is what I'm doing here. I'm going to tell Python to take the data frame and do a pivot table. I want in the index the water body number. The values are going to come from the load of Q1 and Q2 determinants. And in the columns, I want to see the feature type. And wherever you have more than one discharge of the same type in a particular water body, I want you to add up the loads. So the aggregate function is sum. And it creates this nice table that it will tell you for each water body and for each determinant what is the sum of the loads coming from all of the discharges and all of the industrial discharges separately. So this is just an example of how we can retrieve data from the model, carry out merge or join operations in many different ways, calculate outputs from that data, and then summarize very quickly and very intuitively that data into summary statistics and summary tables. Next, we're going to discuss toolboxes. Toolboxes are one of the best ways that you can automate geoprocessing. Another way, for example, would be using the model builder, which does a similar thing, but what I think toolboxes do better is that they provide a user interface that makes it much more friendly to share the automation and to allow other people to use the work that you have done as a tool. I will be showcasing one toolbox in this tutorial. Before we do that, I would like to do a notable mention of the Layer Integrity Toolbox, which is already packaged with the SAGIS add-in. And what it does is basically it checks your SAGIS model for common issues that would be putting at risk the integrity of the model in some of the most common data sets, such as sim features, SAGIS point feature load, and so on. It will check different fields for format, length, invalid characters, and just make sure that, for example, your unique reference fields are indeed unique in some of those tables. So this is one example of automation that I find incredibly useful. Another example, for example, is this Change Plots tool. Now I'm going to open this tool. What this tool does is it carries out change plots for specific sections of your model. Much like the tool that we have already featured, Excel Graphs River Change, but whereas this is a completely different beast of a tool, this is an exploratory tool that will load all of the information in the model outputs and will allow you to explore ridge by ridge as you see necessary, and it will provide a range of statistics and plots immediately. The purpose of this tool is to provide report-ready plots for specific parts of the model. So allow me to demonstrate. I've got my phosphate outputs, and I'm going to select a specific part of the river. The way I've done that is by creating a feature class that contains only the part of the river that I'm interested in, which is this small chunk here. As you can see, I'll remove this one as well, just so it's clear what we're going to be plotting. So I'll simply select that feature class, which I'm calling my river, and press run. And then in your figures folder inside the ArcGIS Pro project, which has been created by default if it didn't exist, you will have a plot showing the simulation calibration outputs on the top and the apportionment at the bottom, which in this case is very marked and dominated by this test sewage streaming work discharge, that it's discharging a lot of phosphorus, which we have made this way, just as I think I've mentioned in previous videos, to be easy to identify in the map exactly where the changes are happening. I'll show a more realistic example next. Now, as a curiosity, or as a useful bit of information, imagine you don't remember exactly where your project has been stored. You could create a variable and run the following command, arcpy.mp. and select the first option, ArcGIS project, and just use the keyword current. So this will get a reference to your current ArcGIS Pro project, which aprx dot, and then I'm going to use the method, or the access the property rather, home folder, and that way you can find where your project is stored very quickly, very easily. Now, let's take a look at how we can plot a different section of the river. So if we bring the outputs back, let's do, for example, the northwest section of the model. So it's as simple as selecting the part of the river ridge that you want. Send here. I'll select a little bit more. We go 33, 34. I think there's a small chunk here, yeah. Oops. It's okay. 35 and perhaps 36. And now, if we right-click on Sim Reaches, Selection, and Make Layer from Selected Features, I'm going to clear everything, and I'll just remove Sim Reaches. As you can see, that has created a smaller version of Sim Reaches that contains only the reaches that we selected. Now I'm going to call this, for example, my second plot. Just press OK. And if we select it here and rerun the tool, This will create a second plot. As you can see, the plots are named after the determinant, followed by that file name, followed by start and end reaches. This gives you a plot where we have no point sources, therefore it's all livestock and arable and very low concentrations for phosphorus. Now, this is an example of automation. Now, what does this look like in terms of the work necessary to automate this process? So there's a template, a default template for Python toolboxes that you can download from the Esri website. I'll show how to do that at the end of the video. And in this template, you would be defining a toolbox as a class object, and then its tool, it's contained into this toolbox, is a separated class tool object, and we need to define all of the parameters that the tool takes, that you've been seeing in the user interface, and then passing them to the code that basically takes these parameters and executes the work, the different geoprocesses and tasks that are required. Finally, we're going to discuss add-ins. Add-ins need to be written in C#. This is because ArcGIS Pro is written itself in C#, and the core of the add-in that allows it to compile and be installed requires that language. That being said, add-ins can and usually contain a lot of Python to drive the geoprocessing. The reason for this is that it is arguably easier to produce code in Python than it is to do in C#. Now, this is a very simple add-in that requires no Python. It's a button. All you do is click on it, and it will tell you your project path, and it will also tell you where the add-in itself is installed. Other add-ins that you may know of is obviously the SAGIS add-in and also the SAGIS model update that we have already featured in a previous video. Now, I would like to show what the add-in is on the inside. If we navigate to the ArcGIS Pro Add-in that you may have installed in your computer, what I'm going to do now is, having enabled suffixes in my Windows Explorer, I'm going to change the suffix to .zip. It will prompt me, oh, this might make the add-in unusable. That is fine. Indeed, you shouldn't do this. It's going to be unusable. What I want to show is that the add-in is actually nothing more than a series of files that have been packaged. And in particular, I think it's interesting to take a look at executables, which contain a couple of files here to run the Lex model, or we could take a look at the installation folder that contains the toolboxes that constitute the SAGIS add-in, as well as the code. So for example, in order to run open and update, we use this Python toolbox, and you can find a similar folder called open and update, which contains all of the code required to run open and update. In fact, if you navigate to project and then add-in manager, it shows you where the add-in is installed, which is following this F97 long string of text to identify the add-in. Every add-in needs to have a unique identifier. Now, if we navigate to that folder instead, you'll see the exact same thing. So this is what is installed in your computer that has been copied from the zip file that is your add-in. And as you can see, you got the toolboxes here. You can indeed go to one of your ArcGIS Pro projects, and if you add to the list of folders in your catalog that folder, or in this case, the folder containing the toolboxes for the SAGIS geoprocessing, let's actually add the same folder. I'll just copy this folder, come back here, right-click, add a folder connection, and I'll just add this folder. Now, I could, for example, open the Open and Update toolbox here and say Open and Update routine. And what you will get is all of the parameters that Open and Update takes. Not only the ones that are shown via the user interface. This is a bespoke user interface that contains the parameters that are optional and the user can specify. But Open and Update indeed uses many more parameters that are required to carry out the process. So all of the code in the add-in is composed of a C# part for user interface, panels, bringing everything together, and so on, and then the geoprocessing, which is usually carried out in Python using a series of toolboxes and their associated many Python files. I would like to finish this video by providing some resources that you can use to expand your own knowledge about Python and ArcGIS Pro. The main resource I would recommend for Python, and I'm talking about using Python in ArcGIS Pro, of course not learning about Python itself, is the Esri website, ArcGIS Pro Python reference. So in this website you can find everything from your get started, how to use Python in ArcGIS Pro, what is the ArcPy library that we mentioned, Python concepts. It will also provide a little bit of an introduction to Python, but I wouldn't use it exclusively to learn Python. It also talks about how to access geoprocessing tools that we've touched briefly, ArcPy functions and classes such as toolboxes and the tools, and many more things. Another useful resource is the communities, in particular the developers community from Esri. Think Stack Overflow, but for ArcGIS Pro users. Some communities that might be useful are ArcGIS API for Python, the ArcGIS Pro Software Development Kit, which would be used to build add-ins, for example, the Developers General Forum, and also the Python Forum, of course. Another useful resource is the Esri Developer website that provides a lot of documentation on how to develop in Esri. So if we go to documentation, for example, and we're interested on Python, one useful bit of information would be here in ArcPy. So we quickly take a look at here. It will take you back to the ArcGIS Pro reference that we saw before. Another useful bit of information is, for example, if you are working in ArcGIS Pro and want to build an add-in, ArcGIS Pro Software Development Kit for .NET. And if you go, for example, to tutorials, there is a very useful tutorial called Build Your First Add-in that will take you step by step to building a very simple add-in, and it could be a very good starting point if this is your learning objective. And this was the end of the video. Thank you very much for watching. I hope you found it a useful introduction to how to use Python in ArcGIS Pro, and happy modeling. Or we should say this time, happy coding.